You've seen the videos, right? Robots that can move with this incredible, almost breathtaking grace. But what if all this amazing technology is really just a mirror? A mirror that's showing us something we're starting to lose in ourselves. That's a huge paradox we're going to get into today. This quote from Terence Hughes, it just hits the nail on the head. It's the whole reason we're doing this explainer. Think about it. At the exact same time we're pouring billions into engineering robotic movement, are we kind of forgetting how to move ourselves? Let's unpack that. So first, let's just take a moment and appreciate the sheer wonder of modern robotics. The stuff these machines can do now, dancing, jumping, performing these really complex tasks, it is an absolutely incredible feat of engineering. And we're not talking about some niche hobby here. This is a massive effort. We are spending billions with a B, on this singular challenge, trying to make metal and code move with the same kind of fluidity and grace as a living thing. The goal is literally to replicate what nature seems to do so effortlessly. Okay, so what does it actually take to make that happen? How do you get a robot to do something as mind-bogglingly complex as, say, a sword dance? Well, it's way more than just programming a few simple A to B moves. For a robot to pull this off, engineers have to hard code a whole library of skills. We're talking about total, full-body control and coordination, a sense of timing and rhythm, the ability to just change direction on a dime at high speed without toppling over, and the superfine motor control to handle an object. Oh, and here's the kicker. It has to land jumps cleanly and constantly adjust for tiny errors, all in real time. And to make all of that work, the robot in this example needs 55 independently moving joints. Just let that sink in for a second. 55 separate parts, all working in perfect, seamless harmony, orchestrated by a super advanced AI. That's the staggering level of complexity we're trying to build here. So, what the engineers are really building is something they call integrated movement intelligence. You can think of it as like a physical brain for the robot. It's this constant background ability to know its own center of mass, to manage the forces of its own movement, and to coordinate its entire body to stay balanced. This is one of the biggest challenges in robotics, and, as we're about to see, it's something we humans are just born with. And that right there, that brings us to the absolute core of this paradox. While we are painstakingly building this intelligence from the ground up in machines, what's happening to the biological version we already have? This is where the story takes a really interesting turn. Just look at this stark contrast. On one side, you have these incredibly complex integrated skills that robots have to learn. And on the other side, you've got our own physical education, which, well, it often just boils down to isolated drills, repetitive exercises, and running laps. We're teaching the components, not the whole brilliant integrated system. This whole approach is what you might call reductionist fitness. You know the drill, right? We break our bodies down into parts. We do cardio for the heart. We do crunches for the abs, specific lifts for specific muscles. We literally have entire classes dedicated to just bums, tums, and thighs. We've somehow started to see our bodies as just a collection of parts, not as a single, intelligent, connected system. And this quote just puts it perfectly. We treat ourselves like cars. We're always focusing on the individual parts that might need a tune-up, instead of nurturing the incredible, self-organizing intelligence of the driver, which is our own nervous system. And this disconnect, this habit of treating our amazing biological bodies like simple machines, has created a massive problem, one that's been called an invisible epidemic. It's the hidden cost of simplifying something that is, by its very nature, incredibly complex, and it's happening all around us. And here's the heart of it. Look, we all do movement. We run, we play sports, we dance, but how often are we actually taught the fundamental principles behind it all? You know, how to sense our own center of mass, how to manage our balance efficiently, how to move as one coordinated whole. It's like we're performing the action without ever truly understanding the incredible intelligence that makes it all possible in the first place. When you lay it out like this, the contrast in our priorities is just, well, it's kind of shocking. For us humans, with our elegant, self-organizing biological systems, we apply a simplified, mechanized education. But for robots, for these engineered systems, we're investing billions of dollars to teach them the integrated, whole-system intelligence that we are actively neglecting in ourselves. It's a bizarre reversal. So here's the ultimate irony, right? While so many of us are worried about AI taking our jobs, we are spending a fortune to engineer solutions for a de-skilling problem we literally created ourselves. We're building this intelligence in machines because we've basically stopped cultivating it in our own bodies. All of this, the whole thing, brings us right back to that big central question we started with. Looking at all this, is this really progress? Let's just state it as plainly as possible. There seems to be this strange inverse relationship going on here. As our ability to build artificial movement intelligence goes through the roof, our commitment to cultivating our own natural biological movement intelligence seems to be taking a nosedive. And that leaves us with this final, and I think pretty thought-provoking question. We're in this massive race to build artificial intelligence that can think and create and move just like us. But in that process, are we accidentally forgetting the incredible biological intelligence we were all born with? As we build this shiny new future, what exactly are we leaving behind?